Hello friends, how are you? Hope you are doing well. In this video we will solve this problem. Okay, here we got memory cells and we have said that we have to subtract the value of memory cell AA or value of memory address A from the value of memory address AV, and have to place the result at address AC, memory address AC, and we are told that the values are encoded in 2's complement, right? So first of all, the subtracting. Let's talk about the subtraction here. The description or the program or this machine language manual we got here, there is no way to subtract values. But what we can do, we can think in this way. See, we are told to subtract a from we are told to subtract the value of memory address A from the value of memory address AB, right? Since we don't have the minus thing in our language, so we can just make this other number, this number negative, the value this memory address got. Okay, just we will make that number into negative number, and then we will just add the value value of memory address AB and the negative value here we just got, right? So if we add like this, so yes, it will also be just subtraction, right? So this is the beginning of the trick. Okay, and now how we will make the value of memory address A into negative A. In our programming language, do you got any such things that will help us to make positive to negative? Yes, we got some. We got. So, but to understand that, we need few things to clear. See, first of all, how will we make the number negative? See, here this a number in 4-bit. Anyway, the how to say, every memory cells we got actually can hold 8-bit of data. So in this case everything will be in 8-bit, and even though if it was 7, so yes, so there will be four more zeros in front of this. Okay, but to make this thing simple here, just to understand, we are using 4-bit here. So in that case, this 4-bit in 2's complement, and if the number is positive, there is no difference between just general binary and 2's complement, it's same, right? So, and this is the sign bit, right? This is 0, that means positive number in that case. So this means 7, right? And how to make this number negative from positive number to negative? So for 2's complement, we just need to flip the values, these values first. So if you flip, you got this number, right? And then we will add 1 with the flipped value. As a result, we will get a new bit pattern, which is this one, this okay, which is this one. Okay, no, I did wrong. Anyway, so we got okay, this is positive, and after flipping the values and adding 1, we got -7. So this is the +7, and this is now the -7. Okay, got it? So after adding these things, we got -7, and if you add this, you will get these bit patterns. So, and then see, so this means positive, that means positive 7, and this that means -7. So if we add these things up like addition, so we should get 0, right? Since this means +7, this means -7, this and this, since these are in 2's complement, right? So see, if we add this thing, we will get this bit pattern, this bit pattern. And since we are using 4-bit to do the two's complementing, so here we got extra 1 here, or here we got extra 1 bit, right? These are 5 bits here. So if we got more than the bits, we, like, how to say, since here we got 4-bit 4 and here also 4-bit, and we added those up, and now we got 5-bit answer of 5-bit. So in that case, the first value will be removed. Okay, so we don't need to care about the first values if we got more than the bits we have here. So see, we remove first value, it was 1, right, and we removed it, and now we found the answer is 0 0 0 0, so that means 0. So actually this is correct, right? The process we just did is correct. Okay, so this is how we will make the positive number into negative number, and then we will just add those two numbers, right? So this is how we will do subtraction. And the other thing is, yeah, now we know how to do the subtraction, make the positive to negative, and how to do subtraction by adding. Okay. Anyway, and then there's another question. We flipped here in our head, it's so easy, but since computers are too dumb, they don't know how to flip. So how can we flip the values using this this machine language manual, or this machine language, I mean. Yeah, so there is another trick to flip the bits. So okay, let's see here. Yeah, here. So see, this is 7, right, and this is 4-bit, and if we exclusive OR this 4-bit with 4 ones, right, so then it will get flipped. And see, this is the flipped value we found after doing exclusive OR here, and here is also the flipped value that we did in our head. So and unfortunately there we got XOR operator in our language. See, in 9 we got XOR operator, and you can read this to find out what, yeah, you can read this. It's nothing, just we have to just exclusive all the bit patterns in register S and T. So S is register, T is register, and we will exclusive all these two values of these two registers and place the result in register R, right? And the output code is 9. So see, we got exclusive OR, so we know we can flip. And in that case, since I use 4-bit here, so to make the number flipped, we have to exclusive OR this number with 4 bits, and every bit will be 1. And if these are 8 bits, so in that case we have to use 8 ones. We have to XOR or exclusive OR with 8 ones. As a result, the value will get flipped. So now we know how to flip, and we know how to add. We got OP code 5. And using that we can add, right? Okay. So this is the trick, and if you understand these things, so yeah, so actually there is nothing more into this question actually, and we are about to done. Now we just need to show our things, right? Okay, so see here, I already wrote the instructions here, and see, first of all, I will just write these things down in my paper, so that to answer, it's like, yeah, the thing like that I'm answering, or how to say, because many of you don't, even though you understand, but you got confused that how to answer, right? So anyway, you can just first write these things down in a column, or just make a 3 column. Okay, let me show. Here you got columns, these are rows, and and this is the column for holding the memory addresses, and this is for our instruction, and this is for the node. So addresses here, addresses and instructions, or you can say contents in here, contents, yes, and this is our node. Anyway, I can't write. So these are the contents, and also this is, anyway, in that case we also can say program counter values, but anyway, don't need to care all about that. Just write this as addresses, and the second is like contents, and the last is node. Okay, so the node column will hold these values we got here. So first of all, since I can understand what I did here, so I will write these things down first, and then I will convert this instruction into the machine language. Okay, so and how I will convert, I will just look at the manual in the appendix C, so that I can easily, just from this line I can easily convert to this. Okay, so anyway, so see what I did first. I loaded the value of memory address AA into register 0, and again loaded the value of memory address AB into register 1. And we know that to flip the value of memory address AA, right? To flip the value of memory address AA, we need 1, and we need 1 for just adding after flipping the values, and also we need 8 ones, since in that case every every numbers or every memory cell can hold like 8 bits of data. So in that case we have to flip the values of that memory address. We need to XOR with 8 ones, okay, or exclusive or with 8 ones, and 8 ones means this one in hexa, right? 8 1 means this one in hexadecimal, and I hope you know that. So, and we also got 1 because after flipping we will add 1 to that value to make it negative, right? So this is why I also loaded these values into our registers, because our processor, and where our processor will find those values that we need to make the positive number into negative. He will look at, the processor will look for it will look into its registers. So this is why we need to also load these values into registers, so that our processor can get these values and do computation. Okay, so see, we got all our tools in our registers. So now we are trying to make the value of memory address A, so here, so means register 0 into negative number, right? So to do that, I took another registers, right, register 4, and here I flipped the value. See, this is the value of register 4, register 0, which means the value of memory address A, right? And then I XOR with register 3, and register 3 means A5, right? Means 8 ones. So see, in that case, register 0, the value register 0 holds, since it holds 8 bit, the bit pattern has 8 bit in it, right? And we don't know what the value is. Okay, we don't care about the value because the value will be given by the user, maybe, or some other way there are some other way that the input will be given. Okay, there may be. So anyway, we got the value of memory address A, right? The value of memory address A in register 0, and here is a register 0, and we XOR with register 3, and register 3 means this one, so that means 8 ones, right? So see, in that line, if you think, if you just think a little, you'll find that in this line we did this thing, and the number got flipped, and so then we will just store the result like this result. Here are in 4 bits, but there is in 8 bits anyway, so we will store the result into our register 4. Okay, so we just flipped the values of register 0, and which is, I hope we got it since we loaded this one here. So we just flipped here, flip the value of register 0, and now we need to add 1 to the flipped value, and since we loaded the flipped value into register 4, so now we need to add 1 in the value of register 4, and for that we took another register. Okay, so see what value we put in register 5 here, the value of register 4, which is the flipped value, right? The flipped value, and the value of register 2, which means here 1, right? So here we flipped, and with the flipped value we added 1, right? We added 1. See, register 2, here is 1, yeah, we added 1. So as a result, in register 5 now we got the negative value of register 0. Okay, and since register 0 holds the value of memory address A, so the value of memory address, we just changed the value of memory address A into from positive to negative number. Okay, so see, so here is the here is the negative value, right? We did flipped, then we added 1, and we loaded value into register 5. So since we got our negative number and we also got our positive positive number, and now we will just add those two numbers, right? So see, in next line, see, this is register 1 plus register 5. That means, register 1 is the value of memory address AB, and the flipped value of memory address A is in register 5, right? So then we just added those two, and we just load, keep the result in register 6. So register 6 now holds the answer that we are looking for. Okay, so we are done, and the last thing is we have to store the value answer, the answer value we just got, into memory address AC. So this is why, see, memory address AC equal register 6. Okay, so that's it, and then our program will stop. I will first write these things. Okay, I got it. So I will write first these things in these columns, right? And then I will convert these lines one by one into the machine instruction, and I put these things in this contents column. And since in this question there is it didn't ask for program counter or the memory addresses, so it's not necessary. I'm not sure, but it's not necessary to put the addresses. But if you want, you can just put 00 here, and 02, 04, 06, 08, and so on. Okay, so yeah, that's it. I guess if you watched all the videos, it won't be that hard to understand. And the main thing is, if you directly try to write these things, so it will be hard, right? So first write these things, and actually if you can write these things without writing these are not necessary to write. This is just for you, because here you can think this as just your pseudocode. Okay, and then you converted the pseudocode into the machine instruction. Okay, that's it. And yeah, you are done. Hope you like it. If you like this video, please like, how to say, please press the like button. And if you have any question, please comment in the in a comment section. And bye bye for now.